All right, this number 1 in the warm-up said find the indicated measure, and this time it wants the circumference. It gives you the radius, and I told you to use pi as 3.14, right? Yeah. So what's the formula we can use for circumference when we're given the radius? 2 times pi times r. So this would be 2 times 3.14 times r, which is 13. This we will do a lot if you want to memorize that. That's 6.28, but that will happen a lot. So if you kind of like just memorize that, it makes your life a little bit easier. And then 6.28 times 13 is 81.64. And it's in inches. Good so far? Yep. Okay, number 2 says find the indicated measure. This time we're looking at the radius, and I told you to use the calculator round to the nearest tenth. So this time, same formula, except I'm given different kinds of information. I'm actually given the circumference, and I don't know the radius. So first thing I could do is divide by 2. And then I want to divide by pi, and that's what I need my calculator for. If it said to leave it in terms of pi, it would actually be 24 over pi, but because I said use your calculator, you're going to divide 24 by pi, the pi button on your calculator, and I get r equals 7.63 or 7.6. Easy stuff, right? Okay, 3 says find the indicated measure. Again, this time I'm looking at the length of AB, and I told you to keep it in terms of pi. What's the formula for the length of AB?
Length equals measure over 360 times 2 times 2 times r times
or if I had diameter to pi d, right? This makes me laugh every time because when you're like taught, you know, like for a week we talked about length, and then I went to like do the review or something, and somebody's like, "Who's Mark?" And I was like, "You've got to be kidding me. That means that you have not heard a word I've said for the last 3 days, because that's the measure of the arc. That's not Mark. I mean, if you want to remember that to help you with, that's fine. But I was close to strangling that child. All right, so this one says 55 is the measure of the arc. So 55 goes over 360 times 2 pi. The radius this time is 9. All right, so because I'm saying keep it in terms of pi, this would, if you can think about not having a calculator on this portion, I would try to simplify it as much as I can, right? So like I can go anywhere you want, but 2 into 360 would be 180. 9 goes in at 180 20 times. And then I have 55 over 20. 5 goes into both of those. That would be 11, and this would be 4. So the most simplified form would be 11 is 11's the only thing over here. Pi is the only thing left over here, so 11 pi over the only thing in the denominator is 4. And this time centimeters.
If you don't get it to like the exact...
It could be 11 fourths pi or 11 pi over 4. It doesn't matter. Either way. As long as both of them are in the top and nothing's at the bottom but the 4, it's fine. Is that your question?
No, because I didn't do it like that. Like 360 divided by 2 to get 180, and then I could have like...
It just makes it easier.
But what if I get like, I got like 11 over, I think,
You did 11 over 72, and then 2 goes into 72, 36 times, 9 goes into 36, 4 times. It's still the same thing.
Oh, I have to divide.
Yeah, everything's got to be simplified as much as you possibly can. Yeah.
I got 198 over 72.
You can keep going. Yep.
Okay, so the length is a portion of the circumference.
Correct.
And the
It's like the slice of the pizza. That crust is the length. Yep. All right. This says find the total circumference of the circles and then keep them in terms of pi. 32. If I go left to right, 32 is given to me. That means this is 16 and 16. If I go top to bottom, it's already giving it to me as 16 and 16. So there's 2 of identical circles. Those are 2 congruent circles, which means I can just find the circumference of one and double it, right? So if 16 is my diameter, then the circumference, we can now use pi d. Pi times 16, or 16 pi is the circumference of one triangle, and then one circle, sorry, and then I just double it. 32 pi. Yeah, and if you know from the get-go that it'd be twice it, you could just use that 32. It's the same thing. Number 5 says find the indicated measure. This time I want the radius, and I told you to make that length 42 pi. So length, again, equals the measure of the arc over 360 times 2 pi r. The length is given to us this time, 42 pi, would equal the measure of the arc is 110 over 360 times 2 times pi r is what I don't know. Now I can simplify this any way I want, but I can, one thing that's super easy is cross through my zeros. And I get 42 pi equals, I'm at 11 over 36 times 2 pi r. 2 can go into that 36, 18 times. And now the right side is as simplified as it gets, 11 over 18 pi r. I want to get rid of the pi's. I can divide both sides by pi. They're gone. And I get 42 equals 11 over 18 r. I can, in one step, multiply by the reciprocal, or I can multiply by 18 and then divide by 11. It doesn't matter how you do that. These are gone.
756 over 11.
Thank you. 756 over 11, and then pi can either be up here, or it could be 756.
You don't have pi, you cross it.
Oh, thank you. Like that. Okay? That's as simplified as it gets. I don't need you to rewrite that in mixed number form. I'd actually prefer it to be left improper. And this would be centimeters. We still good? Okay. This is the last one, right? Yeah. Circumference. So this time I said use the calculator, round it to the nearest tenth. I gave you the length of this arc and the measure of the angle. So the length, which is 92.8, equals the measure of the arc, 150 over 360, times, I want circumference. 2 pi r is the circumference, so I can actually just put the c there and solve for c. So I can cross through these and simplify, or use my calculator. 360 times 92.8 divided by 150 is basically what I need to do. But again, you can simplify it first and then do that. So if I just did it straight up, 360 times 92.8 divided by 150, I get my circumference is 222.72, which is 0.7. Questions? Yep.
Can you go back to this?
Anybody? So again, this should be at least half review because we're talking about areas of a circle, and then we're going to find areas of sector. So circumference and arc length go hand in hand, and then areas of a circle and a sector go hand in hand because they use the same formulas. The area of a circle is something we have known for a long time, right? Is pi r squared. R is again the radius. Sometimes it's kept in terms of pi. Sometimes it will tell you to use 3.14. Sometimes you're using the button on your calculator.
For the homework, we're using.
It'll tell you, I think. Yeah. Okay, area of a sector, or sorry, the definition of a sector of a circle is like the actual piece of the pie, if we're talking about the pizza, not just the crust anymore. So the region bounded by 2 radii and the intercepted arc. So this would be one of the radii, this would be the other, here's my intercepted arc. Everything that's in that space would be called a sector of the circle. It can be small or it can be large, it doesn't have to be a specific size, but it's all the way you're filling in the pie now, okay? That's the difference between sector and arc length. The area of the sector, and it's a theorem, but really it's just a formula. And I'd rather you know this side, because yesterday you guys got really confused by that left side. This is what I want you to know. The area of a sector equals the measure of its arc over 360, just like arc length. But instead of multiplying by circumference, we're multiplying times area. So if you think about it, if I have a fourth of the circle, it would be 90 over 360 times the area of the circle. It's the same concept. So this can also be interchanged for area, like if it just said, if we're trying to like maybe solve for area, we can plug A in there, just like we did C for 2 pi r. But that's the formula you're gonna need to know. So for the quiz, 4 formulas, really 5 if you do both for circumference, right? 1 is circumference, then arc length, then area of a sector, okay? So example 1 says, the radius of the circle is 3. Find the area of the sectors determined by the given arc and leave answers in terms of pi. So for each one of these, I need to know that the area of the sector equals the measure of the arc over 360 times pi r squared. So I'll start with A. This would be 50 over 360 times pi times r, which we said is 3, squared. I can cross through my zeros. I get 5 over 36. This becomes 9. And then I can say 9 goes into 36 4 times. And the most simplified form of this would be 5 pi over 4. And now we're talking about area, so our units are squared.
That's pretty much it for this one.
Yup. Then I do 20. 20 over 360 times pi 3 squared. Again, I can cross through my zeros. I can go one step further and say 1 goes into 36 18 times. This becomes 9. Cross through the 9 and the 18. And my answer is just pi over 2 centimeters squared. $140 over 360 times pi 3 squared. Cancel these out. I can divide by 2. 7 over 18 times pi times 9. 9 goes into 18 twice, and I get 7 pi over 2 centimeters squared. And the last one, 210 over 360 times pi r squared, which is 9. Cross through my zeros. 3 goes into both of those again. That would be 7 over 12 times pi times 9. 9 and 12 are both divisible by 3. This time I got to multiply all these out. 7 times pi times 3, 21 pi over, the only thing in the denominator is 4. And again, centimeters squared. Easy stuff, right? Oh, sure. Sorry, McKenna. So just like the variations on like length, you could also see it where it gives you the area of the sector. You got to work your way backwards. Same concept, okay? You'd solve for whatever variable is left. And then there's usually some application with shapes in this. Sometimes you'll see like a shape within a shape and it will ask you to find the area of it. You've got to find the two shapes, subtract one that's missing, that kind of thing. This example says find the area of the region bounded by segment AB and arc AB. Leave the answers in terms of pi. So the area bounded by segment AB, so here's segment AB, and arc AB is actually this area in here.
Wait, what do we do? So since that's the center angle, 120 over 360 times pi 6 squared.
So if I did the area of this sector for this, I'm gonna get that whole thing, right?
You have to get that whole
And then I have to do what?
divide.
Subtract what? The area of this, yes?
Oh, yeah.
So if I want just this area, right? I want just this area here. That is not a shape you know how to find area of, right? You can find the area of the whole sector, which is what we're doing now. And then, do you know how to find the area of a triangle?
Yeah.
Yeah, so we can find the area of that triangle and subtract it from the area of the sector. Does that make sense? So we're going to do area of the sector and subtract from it the area of the triangle. So the area of the sector is 120 over 360 times pi, my radius is 6, squared. Cancels. 1/3 times pi times 36. 3 goes into 36, 12 times. So the area of this sector is 12 pi. Now I want to find the area of that triangle. How do you do that? 1/2 times base times height would give me the area of that triangle, right? But
It's a sausage.
do you know the base?
No.
Do you know the height? No, what do we know about this triangle? What just happened when I cut that?
Is that sausage? So basically,
It is isosceles, so those are two congruent triangles. But what happened to that 120 when I drew that with an altitude, right? Cuts it into two 30, 60, 90 triangles. Yay, they're back. This is my 30, right? So really what I have is two of these. Do you remember the relationship of the sides in your 30, 60, 90?
A radical 2 or?
A root 3. Oh, I switched those. Sorry, hang on. This is your 2A. This is your A root 3. So A is 3, which means the height of this triangle is 3. Okay? You can use the base as 3 root 3. Okay? But then you'd have to double it. Or you can just find the area of one of those triangles and multiply by 2. It's the exact same thing. Okay? So if I find the area of the whole triangle, it's 1/2 the base, which is 3 root 3 plus 3 root 3, 6 root 3, times the height, which is this side, we just said is 3. This is 9 root 3. That's the area of that. Oh.
How do we subtract 9 root 3 if we don't have a calculator?
So without a calculator, it would actually stay exactly like that. Yep. And we don't even have a unit on it, right? So units. With a calculator, you would work it out. If they both happen to have like pi on them, then you would just subtract. Like if it's 12 pi minus 5 pi, it's 7 pi, right? But if one has a pi and one doesn't, or one has a square root and one doesn't, you would leave it exactly like that.
And for the quiz, are we gonna have, for the last section, are we gonna have questions where we can use a calculator?
Nope, not on the quiz.
It's gonna be one specific way to do it.
Quiz will either say use 3.14 or keep in terms of pi.
Or will be both? Or will it-
Alternating between the questions. Yeah, but no calculator for the quiz. Yeah, I think tests, we're going to separate them out because we have to separate out part of 11.4. We haven't made your test yet, but we have to separate out 11.4 calculator use, so you'll probably have a part of your test you can use a calculator and a part that you can't. We'll go back to that. Okay. Questions? So that question right there is a great standardized test question because it puts together a bunch of different stuff. Of course, that's what they like to do, right? And that 30, 60, 90 triangle is not going anywhere, okay? They could be all different kinds of shapes, though. You could get a square inside the triangle, and you have to subtract the area of the square away from it's square inside a circle, and you have to subtract the area of the square away from the circle. Or you could get a bigger triangle inside. All that good stuff, like you'll get some application of that stuff. Okay, and actually,